positive. Well, okay. This told us we had to do v minus w first. Remember that for number 8? Down here, this has the magnitude of each vector, then subtract. So that's what we've got to find. So if we use our little vector sheet here, to find the magnitude of each vector, we're just going to take the a or the x squared plus the b or the y squared, whatever you call it, and take the square root of it. That's how we're going to get our magnitude. Okay, so here we go. Let's first find the magnitude of v. So the magnitude of v, okay, our x or our a is going to be -4, and our y or our b is going to be +5. So we're going to take each one of those and we're going to square them. Okay, we get 16 plus 25, which is root of 41. There's nothing I can do with that, so I'll leave it. Okay, now we want the magnitude of w. So our x or our a is 2, and our y or our b is -3. So we're going to square 2, and we're going to square -3. Okay, and we're going to get 4 plus 9, which is square root of 13. I can't do anything with that either. Is everybody okay with how we get magnitude? It's really the same thing as r. That's all. Just find an r. Okay, then this wants us to take the magnitude of v minus the magnitude of w. All right, now you got to think back to your algebra rules. Algebra rules say you cannot combine radicals unless the index and the radicand are the same. The radicand's just the stuff under there. So these are not the same. So there is nothing you can do. You're done. Okay. Sound okay? All right. Let's see. Okay, now number 10, which is like my Math Lab 15, and number 11, which is like my Math Lab 16, are the same type of problem. So we're only going to do one, and we're actually going to do number 11 because it's a little bit harder. Just has a little bit harder algebra in it. You have to rationalize. So I thought we'll do that one. So I'm going to skip number 10, but same directions. They give you a vector and they want you to find the unit vector that has the same direction. Okay, so remember, to find a unit vector, you're going to take the vector they give you and divide it by the magnitude. That's it. Okay, well, we have a vector. That's going to be our numerator. Our denominator is going to be, so I guess I could write it over here. Okay, actually they call it u. Anytime you have a unit vector, they call it u, regardless of what letter you have. Divided by the magnitude. So let's find our magnitude. Remember, it's the square root of your a or your x component squared plus your b or your y component squared. So I'm going to have 144 plus 25 is 169. I can do something with that. Anybody recognize the square root of 169? That's 13. Yeah, you knew that. Oh, shoot, I did the wrong one. I just said we were going to skip it, and then I did the stupid thing. Dang it. Well, I guess we're doing that one. Okay. Did you say you're going to exit out?
I exited out.
Oh, you exited out.
Yeah, and I was like,
And I just took off. Like, yeah, there we go. Okay. So, all right, unit here. Here's our unit vector. Okay, so I want the whole vector on the top. Okay, here's my vector, v. And I'm going to divide it by 13. Okay, now you have to have two separate pieces. You have to split it up. So I'm going to have -12 over 13i minus 5 over 13j, and I can't reduce either one of those. So I'm done. Okay, that's kind of the gist of it. All right, let me tell you why I was going to do number 11, why I thought it was a little harder. Because when you find the magnitude of this dude, he ends up being the root of 65. which looks like you ought to be able to reduce it, but you can't. Okay, so I'll just go ahead and let you know that. So when I do the unit vector, okay, and then when I split it up, I am not allowed to have a radical in the denominator. So that's why I was going to do this one, because you're going to have to rationalize both terms. That's why. So I would have to multiply the top and the bottom of every term by the root of 65. I just wanted you to know that sometimes your unit vectors have to be rationalized. And so what you're going to end up with is 4 root of 65 over 65i minus 7 root of 65 over 65 times j. So that's why I was going to do that one, just so you know. Worst case scenario, you have to rationalize. Not hard. Okay, everybody all right on unit vectors? Real simple. Kind of your reward for making it through that last test we had to do, right? Okay. All right, number 12, we're looking at number 17 on my math lab. Okay, our directions say, write the vector in this form. Okay, so with the I and the J, given its magnitude, so they give us the magnitude, and they give us an angle, they give us alpha, okay? And that's what it makes with the positive x-axis. So if you don't like alpha and you want to turn him into theta, you can use theta. Vectors normally use alpha, but if you like it better, you can. So in order to get vector v in this form, what we're going to do is take the magnitude, which is kind of like r, times cosine of your angle I plus sine of your angle j. It looks a whole lot like what we did with polar form, right? Only this one has an I and a J in the back of both of these. Okay, is everybody okay with that? That's the equation you're going to use. All right, so here's my magnitude. Here's my angle. I'm just going to fill it right on in. I'm going to have a 20 out in front. Cosine alpha means cosine of 120 I plus sine of 120 j. All right, I'm going to keep going. 20 out in front. Okay, I'm going to go to my unit circle. What is the cosine and what is the sine of 120? Well, here's 120. My cosine's negative 1/2 and my sine is root of 3 over 2. Okay, so cosine of 120 is going to turn into negative 1/2 I. Hold on, I'm out of control. Okay. Sine of 120 is going to turn into root of 3 over 2j. Okay, I'm still not done. My last step is I'm going to distribute that 20 through there. So 20 times negative 1/2 is negative 10i plus, okay, I'm going to do this in one big step, but 20 times root of 3 over 2 is going to be 10 root of 3. And there's my final answer. It looks a whole lot like this form up here that they wanted. Okay, so that's how you turn it when you have the magnitude and the angle. That's how you turn it into your vector. Okay, sound good? Any questions? All right. Okay, last page of 9.4 then. Okay, we have 3 examples. So in my math lab on this next page, it's going to be 18, 19, and 20 because there's 20 problems. We are going to skip that very last example down there at the bottom because 14 and 15 are the same. Okay, so this is going to be 18, this is going to be 19, and then I'm going to skip 20 because these are exactly the same problem. Okay, let's look at 18. All right, new directions here. Now this wants the direction angle of V given this. It's kind of the opposite. So we came up with this in the last example. the direction angle it's talking about is the alpha. Or if you like theta better, you can use theta instead. But that's what it's wanting. It's based on that last thing that we came up with. How do you find that? Okay, well, here's the deal. This is our A or X, whatever you like to say. And then this guy is B or Y, whatever you like to say. What we know is that tan theta, or you could call him alpha, if you like it better, equals our Y over X. All of these equations work for everything. They work in rectangular form, they work in polar form, they work in vector form, they all work. So in order to find this theta or alpha, I'm going to put positive 5 over negative 5 root of 3. Then it's going to reduce and give me negative 1 over root of 3. Now, before I go searching for that, I need to limit myself to a quadrant. So I need to know what quadrant I'm looking for. Remember, you go back up here to do that. So what I'm looking for is a horizontal component of, that's negative. So now I'm over here on the left, and a vertical component that's positive. So what quadrant does that put me in? 2, right? I go negative, positive, I'm in quadrant 2. Okay, so I'm over here in quadrant 2. I'm looking for a tangent, y over x, that's going to put a root of 3 in the bottom. So I'm not looking at 3 pi over 4. I got to look at one of these. And remember, it's y over x. So this y over x would put the root of 3 in the top. This y over x would put the root of 3 in the bottom, right? This one would be 1/2 over negative root of 3 over 2. That's exactly what I want. So that value, and they want degrees. They didn't say that, but that's what I put. So that must be what they specify as wanting, is 120 degrees. Oh, it's 150. Okay. I don't have Ish here to yell at me. Okay, 150. There we go. Sound good? Okay, if they tell you they want it in radians, then you'd put 5 pi over 6, just whatever they specify. Okay, last type of problem wants the direction angle for the following vector. So I guess this is the same thing. They're all kind of the same thing. So we're going to do the same thing here, but what we're going to find when we get to this point, it's not on the unit circle. And what are we going to do when we find out it's not on the unit circle? Inverse tan, right? And we get a reference angle. So we're going to get a chance to practice our reference angle again. Okay, here we go. So I'm going to do tan theta or tan alpha. I'm going to take this little vertical part, this y or this b, over the horizontal part, which is 9. Now that reduces down to negative 2/3, but this is still not on the unit circle. So we're going to have to go to our calculator. Okay, so this for vectors here, this is telling me to use degree mode. These are just notes that I've made on my packet. So that must be what my math lab is going to tell you, is to use degree mode. So make sure you're switching back to degree mode. I know that you haven't done that in a little bit. Okay. So in our calculator, we're going to do inverse tan of negative 2/3, and we want to be in degree mode. Let's see here. Okay, I know I'm not in degree mode. Go. Inverse tan of negative 2/3, and I get negative 33.69. Okay. All right, this is my reference angle. So it's negative. What are we going to turn it into? Positive. We're going to turn it into positive 33.9. We're going to make it positive. Okay, now that's not my answer. Remember, that's my reference angle. Now I have to know which quadrant do I go into so I know what to do with the reference angle. So I'm back up here. All right, I'm looking at positive 9 -6. So what quadrant am I in? Quad 4. Okay. So if we think about what to do in quad 4, if we go back to the little note that we use, little cheat sheet we use, in quadrant 4, we're going to do 360 degrees minus our reference angle. That's what quad 4 says to do. So I'm going to do 360 minus 33.69, and I came up with 326.3 degrees. Okay. Now, number 15 is also going to allow you to practice this not on the unit circle situation. Let's just make sure we remember how to do a reference angle for this guy. What quadrant is number 15 going to be in? A negative, negative. That's quad 3. Okay, if I'm using degrees, how would I get the reference angle for quad 3? I'm going to do 180 plus our positive reference angle for quad 3. Okay. Everybody okay with all those? All right, vectors are pretty easy. Your dot product's going to be pretty easy too. That's what's coming next. And then we're all done. Okay. Here we go. So this last little section, dot product. What in the world is a dot product? Okay, so we're not going to spend too much time on this first page. And there aren't any MyMathLab questions on the first page. So I'm just going to point out some important equations that we're going to use as we go through it. Okay, first of all, what's a dot product? Okay, so if you take two vectors, let's say vector u and vector v, and they give you the coordinates of each vector, like the x and the y coordinates, and then they put a big old dot between them. That doesn't mean multiplication. It's a little different than multiplication. So we would say this is u dot v. What the dot means is you're going to multiply the x components, multiply the y components, and then add them together. A dot product is one amount. It's just one number, one chunk. Okay. All right. This kind of gives you some properties that will make your mind spin, but they may all make sense. They're very intuitive. We're going to practice them as we go through our examples. What I want to talk about though is what's down here. Okay, so this was kind of the algebraic version of the dot product. Let's talk about geometry version or trig version down here. Okay, if you want to find the dot product, another way you could do it is take the magnitude of each vector, multiply them together, times the cosine of whatever their angle is. Okay. You can also find the cosine or the angle involved with the dot product if you just solve it for that. So we'll do that in our examples. Okay. Another thing to think about, what if you go to do your dot product and it's 0? Is that a big deal? That is a big deal. It's a valid answer and it's one you're going to get a lot, but that also gives you some important information. If you get a dot product of 0, it means that your two vectors are perpendicular. But in trig, we don't say the word perpendicular. We say they are orthogonal. So that means perpendicular. So if your question asks you, are your vectors orthogonal? You're like, I don't know, that's personal, right? So what you're going to do is find the dot product of each one. And if it's 0, yeah. And if it's not 0, if it's anything else, no. There you go. That's how you know it's orthogonal. Also, what would the degrees be if you had two perpendicular vectors? What would the degrees of a perpendicular situation be? That's 90. They form a right angle, right? So sometimes if you can prove that your angle's 90 degrees, that's another way of proving that your vectors are orthogonal. Okay. Now we do let you use the word parallel, so we keep that little guy. Okay, so parallel happens when, and I didn't put this on here, so make sure you write it. Parallel happens when your theta is 180. Okay, so if your theta is 90, you're orthogonal. If your theta is 180, you are parallel. Now, there's no special dot product for parallel. It could be anything. But one kind of interesting little point is that one vector is going to be a multiple of the other vector. And we'll see that when we go through and do it. Okay. All right, last little formula we're going to use is, let's say that you have vector v, and you want to break vector v into two smaller vectors, vector 1 and vector 2. Okay, so when you break it into two smaller, we call that decomposing. So I'm decomposing my vectors. Okay, we want vector 1 to be parallel to another vector, and we want vector 2 to be orthogonal to the other vector. Sounds very complicated, right? It's really not. Here's the little formula. Okay, we have a dot product in the top. We have a magnitude in the bottom. We multiply it by another vector. And then we just got a little subtraction. So it's not hard at all, but the directions are going to seem pretty weighty. Okay. All right, well, let's jump right in. So this, my math lab is very short. There are only, I think there's either 8 or 9, to be honest with you, questions in the whole thing. And that's it. So it's a really short little homework. So we're just going to go through and do the examples, and that'll be that. Okay, so this will be my math lab 1. Okay, so I have two vectors here. I have vector v and I have vector w. Okay, this is what it wants me to find. A says find the dot product. That's my first thing I got to do. Once I do that, it's going to want the angle between them. Once I do that, it wants to know, are the vectors parallel? Are the vectors orthogonal, perpendicular, or are they neither? Are they just regular old vectors? Okay, so let's do A first. Okay, part A. All right, so to find your dot product, v dot w, remember this is not multiplication, this is a dot product. What I'm going to do is take the little coefficient of I from v times the little coefficient of I from w. I'm going to add that to the coefficient of j from v and the coefficient of j from w. Now be careful, what's the coefficient of j for w? -8, right? Watch your signs. If there's a minus, it comes with the number. Okay, you can probably already see what's happening here, but we have a 56 minus a 56. My dot product is 0. Done. Okay, pretty nifty. Now, since I'm 0, this is fantastic. I don't even have to do any complicated work for B or C, because what did I say happens if the dot product is 0? We're orthogonal. So I don't actually have to go through and do the math for the angle between the two, because what's the angle going to be between those two vectors? 90. Now I'm going to go through and show you how to do it for other ones. So I can already tell you this little dude is orthogonal. Done. Okay. So if you get a 0 from the get-go, you don't even have to keep going. Sound like a plan? Okay, everybody okay on the dot product? Okay, let's try one that's not quite as straightforward then. Okay, look at example 2. All right. Okay, same directions. Okay. All right, we have two vectors. One of these guys has a root in it. We got a lot of negatives, so we just want to kind of be on high alert. First step is we want the dot product, okay, of v and w. So I'm going to take the I component of v, -√3, times the I component of w. What's the I component of him? -1. Good. Plus j component, there's another -1, plus the, or I'm sorry, times the j component of w. That's another -1. Okay, so -√3 times -1 is a positive √3. -1 times -1 is 1. Can I combine these guys in any way? No. So there's my dot product. I'm done. Are these two vectors going to be orthogonal? No, because this is not 0. Are they going to be parallel? Well, I don't know. There's really no way for me to tell parallel until we get to the theta. Orthogonal, you can know from every step. Parallel, you have to look at your theta. So I don't know. This is either going to be a neither or a parallel, but I know it's not orthogonal. Okay. All right, let's try the next step. Okay, now we want the angle between them. Okay, so remember, for the angle between them, I'm going to have cosine theta equals the dot product in the top, which just so happens we have from A, times the magnitude of each one multiplied together in the bottom. Okay, well, I already have my numerator, so now let me just work on my magnitudes. So let's see, let me find the magnitude of V. Okay, so I'm going to have the I component squared plus the J component squared. What is negative root of 3 squared? 3. Good. You can always put that in your calculator if you're not sure. Put it in parentheses and put it just like that. Okay, negative 1 squared is just positive 1. Well, this is a pretty little magnitude. Look at that. It's just a plain old 2. Take it. Okay, now let's find the magnitude of W. Okay, so we're going to take the I component squared, the J component squared. I'm going to just get positive 1 plus positive 1. That's a root of 2. Okay, everybody okay on finding those magnitudes? All right, let's find our angle. Cosine of theta is going to be dot product in the top, root of 3 plus 1. Okay, denominator is going to be magnitude of V times the magnitude of W. Okay, all right. Now we need to find theta. Well, I don't know about you, but I don't remember seeing that on the unit circle, which means we're going to go to our calculator. Okay, we're going to do degree mode for these vectors, and it'll tell you that in MyMathLab. Okay, here's where you're just going to have to get really savvy with your parentheses. I mean, sprinkle them like confetti, because the more you have, the better your calculator is going to take this nightmare. All right, so I'm going to show you how I would put it in. I'm going to do inverse cosine of a gigantic thing, which is this. So we're going to have one big set on the whole thing. Then I'm going to have the numerator have its own little set. And then I'm going to have, you don't have to, but I always like to do the denominator its own little set. That's probably a little extreme, but I just like parentheses. And we're going to see what we come up with. Okay, so here we go. It never hurts to have more than you need. All right, we're in degree mode, and we're going to do second cosine. It already gives me my big set, so I'm going to go ahead and put a little set in. Root of 3. Make sure you scoot over so that your plus 1's not under your radical. Divided by, and I'm going to put another set in. You probably really don't need that other set, but I'm going to do it. And then I'm going to close it all. If you're missing one of your parentheses, you're going to get an error. So make sure you close as many as you opened and then hit enter. And I got, after all that nonsense, a big fat 15. That's going to be your answer. Okay. Everybody okay with that? If you have trouble getting it in your calculator, let me know. No, if it's parallel, what would my theta be? 180, right? Good point. So it's not parallel, okay? Which means it's a neither. Okay, it's a neither. Is, well, this would be a 90 degrees, but it would be a 0 dot product. Okay, anybody want to see the calculator again? Okay, did you get it, Roberta? Okay, everybody got it? Okay, good. All right. Okay, so there is that guy. Okay, let's try the next one. Same directions, but I want to make sure that we see every possible scenario happening. I'll let you skip number 4. We'll just kind of set it up. Okay. Okay, number 3, same directions. Okay, we've seen one happen that's orthogonal. We've seen one happen that's neither. You can probably guess what this one is, but let's just check it out. Okay, first thing we're going to do is find the dot product. Feel free to make that a big old fat dot too, because you don't want to confuse it with multiplication, you know. Okay, here we go. So I'm going to take the I component of V times the I component of W plus the J component of V times the J component of W. All right, I'm going to get a negative 63 minus 112. So my dot product is negative 175. Well, it's definitely not orthogonal. Is there any way for me to know if it's parallel yet? No, got to keep going. Okay, so as you can see, your dot product can be anything. It can be positive, it can be negative, it can be radical, it can be 0. I mean, the sky's the limit, so just be aware of that. Okay, let's look at B. All right, we want to find our theta now. So we're going to have cosine theta equals the dot product, which we know is going to be negative 175, over each magnitude multiplied together. Okay, so let's find our magnitude. So magnitude of V. All right, square root of, it's going to be the I component squared plus the J component squared. That'll be 9 plus 16. Nice little root of 25, which gives me 5. That was handy. Okay, now we want magnitude of W. So square root. All right, we're going to take the I component squared. This is going to be a big boy. Times the J component squared. Okay. I get 441 plus 784. That's the square root of 1,225. But that's a nice number. Comes out to be 35. Okay, that's not bad. All right, here we go. Cosine theta equals, my numerator is my dot product, so negative 175. My denominator is going to be 5 times 35. So that's negative 175 over, oh, I don't know that. Well, isn't that convenient? 175. So what I have is cosine theta equals negative 1. Okay. So now what I can do is put it right in my calculator. Cosine negative, or inverse cosine of negative 1. Okay. And looky what our theta is. It's 180 degrees. So are we orthogonal, parallel, or neither? We're parallel. And I just want to show you something real quick also that helps to prove that it's parallel. And that's if we go back up to the V and the W. Another characteristic of parallel vectors is that one of them is a multiple of the other, which means can you take the smaller one and multiply it by a number and get the bigger one? Okay, so if I take this dude, what number can I multiply him by to get this guy? How about a negative 7? Negative 7 times negative 3 gives me positive 21. Negative 7 times negative 4 is positive 28. So sure enough, that's another characteristic. So sometimes you can tell from the beginning if it's going to be parallel if you pay a lot of close attention to your vectors. Okay, if you look and say, oh gosh, I see a multiple there, then you're going to know. No, you could just gamble and do a 180 if you want. Yeah. Okay. All right, example 4, this one's going to go quick. So let's just look at it real fast. This is the last one of these, and then we'll do some other stuff. Okay, look at these vectors. They're itty bitty and weird. They don't have both components, so they're kind of strange. So let's just look at what that's going to mean for a dot product. Okay, you have to have a component to put in to the dot product. So what am I going to put in for the coefficient of I if it's not there? 0. Then the coefficient of his I is going to be -1. Plus, coefficient of j is 12. What's the coefficient of the j for the w vector? 0. So what's my dot product going to be here? It's 0. So B is 90 degrees, C is orthogonal. And you're done. No. But I just kind of wanted to show you what to do if it's missing a component like that. You're going to still have to put it in, but if it's not there, it's 0. Okay. All right. Sounds good. Okay. All right, let's look at 5. He's a little bitty one. Okay. So what if you really need orthogonal vectors? Now, this is just a beginning trig class, but if you take higher level trig classes, and especially higher level physics classes, because they use vectors in physics, sometimes in certain applications, you really need your vectors to be orthogonal. They have to be, or some of your formulas won't work. Okay, so we have a nice little vector for W. We know we need him. And we have an I component for vector V, but we're just not sure about the vertical component, the Y component of V. I want him to be orthogonal, but I'm not sure what it is. So this sentence looks weird, but what it's saying is find A, which means find this guy. What is the coefficient of this to make these two orthogonal? That's what's happening there. So you guys have done enough algebra. You could probably do this on your own, but let's think about it. So I'm going to find the dot product, but if I know I want my dot product to be orthogonal, what is that going to equal? 0. So I already know it's going to be 0, right? Now let me put my dot product over here with what I have. So the I component of V times the I component of W plus the J component, which I don't know what it is, but I just have a -A in its place right now. So that's what I'm going to throw it in as. If this were plus AJ, I would put a positive A. They're just use A to, I don't know why, hold its place, times the J component. So that's how you're going to set that up. And then you're going to solve for A. Does this setup make sense? This is just replacing the dot product with 0 because we want it to be orthogonal. Is that okay with everybody? Okay, so let's keep going. So we're going to have -2 plus 3A. That's a positive when you multiply those two negatives. All right, we're just going to solve for A. So we get 2 equals 3A. And we divide by 3. And that's what my A is. And then if you wanted to check yourself, if you go back and put 2/3 in right here and do the dot product using 2/3 as minus 2/3 J, you're going to come up with a 0. And then you know that was right. But that in that kind of situation, you can force your vectors to be orthogonal by picking them, basically. Okay. All right, number 6, and 7 and 8, which are the last ones, they're all going to be talking about those little equations from down here at the bottom, these decomposing equations. Okay, we're going to do that for the next few. All right, so we have a vector V and we have a vector W. We want to decompose V. That means we're going to take V and break them into two smaller, V1 and V2, little smaller ones. Okay, now here's the kicker. The V1 has to be parallel to W, and the V2 has to be orthogonal to W. So you can't just split him in two and say, oh, well, you know what? It's 6I plus 2J. That would give you a couple of vectors, right? You have to split it in such a way that they each have a purpose and they relate a certain way to W, okay? So here's what we're gonna do. If you look back, here's how we find V1. We're going to find the dot product of V and W, which we can do, the magnitude of W, and we're going to square it, and then we're going to multiply that by W. That's going to give me a whole new vector, and we're going to call him V1. Okay, so let's write that little formula over. Okay, so to find V1, we're going to find the dot product divided by the magnitude squared, and then we're going to multiply it by W. Okay, that's how we're going to get V1. So we have a lot of work to do because this is a lot of stuff that we need. First thing, let's find the dot product. Okay, so I'm going to take the I component of V times the I component of W and add it for the J component of each one. It's going to give me a negative 12 plus 4. Oh, I'm on the wrong. I was like, that's not what I got. Sorry, I'm on the wrong problem. Okay, I have a nice little dot product of negative 8. Everybody okay with that? All right, let's find the magnitude of W. Remember, that's the square root of the I component squared plus the J component squared. Going to give me a magnitude of root of 2. Okay, that's everything I need. I'm ready to find vector 1. So here we go, vector 1. Dot product in the top, that's a negative 8. All right, I'm going to take the magnitude in the bottom squared. So it'll be negative 2, I'm sorry, root of 2 squared. So that's just going to be a 2 down there, right? And then I'm going to multiply whatever this comes out to be by W, by the whole vector W to create another vector, okay? All right, well, negative 8 over 2 is really negative 4. Okay, everybody agree with that? I just made a little coefficient in the front. And then I know we didn't talk a lot about the distribution rules for vectors because I figured that they were probably something you would come up with anyway, but I'm just going to distribute him. So I'm going to get a vector 1 of positive 4i minus 4j. There's my vector 1. Okay, sound good? Okay, now in order to get vector 2, all you're going to do is subtract the regular vector minus vector 1. So vector 2 is v minus v1. Okay, now remember, put these guys in parentheses because there's an extra hidden step with subtraction, right? You have to distribute that negative. Okay, so I'm going to have to distribute this negative through the back. And then I'm just going to combine like terms. So vector 2 is going to be 8i plus 8j. And then I'm done. Okay, now let's look at these for just a minute and talk about them. All right, so if I just gonna kind of make sure I didn't make a mistake as I was going through here, let's go back and look at our original vector v. Okay, I decomposed v into 2 other vectors. That means if I add these together, they better equal who? Big Daddy V, right? Okay, so 4i plus 8i, that's 12i. Negative 4j plus 8j, 4j. So there we go, awesome. So I did decompose him to 2 vectors. Now, v1 is supposed to be parallel to w. Remember how you can tell if it's parallel? It's a multiple. Can you take the smaller one and multiply it by something to get the bigger one? If I start with this dude, if I multiply each term by, let's say, negative 4, I come up with v1. So he's definitely parallel. Then I want v2 to be orthogonal to w. Well, if you take the dot product of both of these, guess what they're going to be? 0. So you can check this, that every single part of it works, but this is how you come up with it. Okay? Sound like a plan? All right, let's do one more. I don't think we need to do 7 and 8 because they're both exactly the same. They're decomposing. So I'm gonna skip 8 and let's just do 7. Okay. Now that was that one decomposed into really pretty nice little vectors. most of them aren't nice. Most of them are beasts. This guy's a beast. Okay, so just be prepared that you're going to be in fraction land with this guy. Okay, so we want to decompose. So remember, first thing we're going to need is the dot product of v and w. That's going to be the numerator that I need for vector 1. Okay, so I'm going to have my I components multiplied together and added to my j components. Okay, this is going to give me a positive 2 minus 6. I got a dot product of negative 4. Okay, that's not a bad numerator. All right, remember we need a magnitude of w. All right, so I'm going to square my I component and add it to the square of my j component. That's going to give me a 4 plus a 1 is 5. Square root of 5 for my magnitude. Okay. All right, so vector 1, remember, is going to be the dot product of v and w divided by the magnitude of w squared times vector w. So here we go. Negative 4 in the top, square root of 5 squared in the bottom, that's just going to be a plain old 5, times w, which is going to be negative 2i plus j. Okay. All right, I'm going to clean it up a little bit. It looks like we're going to have a negative 4/5 that we're going to distribute through vector w, which is not pretty, but most of them are not pretty. Okay, everybody all right with this so far? Okay, we're going to push it through there. Vector 1 is going to be positive 8/5 I minus 4/5 j. There is vector 1. Yuck. Okay. Well, that wasn't horrible. Here's where it gets a little horrible, is because how do you get vector 2? You got to subtract. I hate subtracting fractions. So I'm going to do it in my calculator. Okay. So remember, vector 2 is going to be vector v minus vector 1. So let's get it set up. Negative I minus 6j minus 8/5 I minus 4/5 j. And we're going to have to distribute that negative. So I'm going to have negative j minus, negative I minus 6j minus 8/5 I plus 4/5 j. Okay. I don't mind doing trig stuff all day long, but like I'd rather be beat than have to do this. So I'm going to do it in my calculator. So let's just look at how to do that. Okay, here we go. See if we can remember. So for my I component, I'm going to take negative 1, so that's it, minus, and then in parentheses, I'm going to put 8/5 and hit enter. Then I'm going to go to math, frac. So negative 13/5 I. Okay. Now for j, I have negative 6 plus parentheses 4/5, enter, and then I go math, frac. Everybody know how to change decimal to a fraction? You comfortable doing that? Okay. Minus 26/5 j. Now that one's not so easy to look at and tell that it came from the vector and it's parallel and all that good stuff. So I'm just going to trust my math. And then there you go. So somehow through the magic of trig, we did it, but we finished the packet. So we are good. Okay. Let me know if you have any trouble with your calculator stuff, but just be ready on Monday. I don't have a study guide for you yet, but I'll have it Monday and we'll review and we'll talk about our index card. We'll make sure that we have plenty of